Hello and welcome one and all. Today we will cover SQLite database and SQLite with Pandas. This is a beginner's guide to SQLite. In this video we will cover what SQLite is, how to connect to a database, create tables, insert and query data, and access SQLite in Pandas. I am going to assume that you have some basic understanding of SQL, and my main focus will be on how to use SQLite in Python. So what is SQLite? SQLite is a software library that provides us with an open source relational database management system where we can store large amount of data. It is easy to set up and it is self-contained. It does not require a server, and a SQLite database is just a plain file, which makes it easily accessible and portable. And given its simplicity, it is the most widely deployed database engine. Okay, enough talk, let's get started. If you would like to follow along, then you can create a new Jupyter Notebook and let's get started. And those of you who are new to Python and want to set up a Jupyter environment, then check out my video on how to set up an environment. Once you're set up, then come back and let's get started with SQLite. Just an FYI, the complete notebook is available on GitHub. Link is in the description below. As usual, we start by importing the required libraries. So we will import the SQLite and Pandas inside our notebook. The SQLite library does not need to be installed as it is included in Python 2.5 and above. First, what we need to do is either connect to an existing database or create a new one if it does not exist. Note that SQLite keeps the database as a file with a .db extension. So the line of code will connect to a file called SQLite.db if it exists, and if it does not, a file called SQLite.db is created on your computer. This database file will be in the same folder as in your notebook. In order to interact with our database, we need to create a cursor. A cursor is used to execute statements to communicate with the database. Using the cursor, you can execute SQL statement, fetch data from result set, and call procedures. We will use this cursor to issue commands that will allow us to query or modify our database. Now we have our database connection and a cursor created. We can now start interacting with the database. Let's create our first table in the database. We will use the method execute on the cursor cn we created earlier, and we pass in our SQL statement. This statement will create a table called employees with 3 columns, empid, first name, and last name. We can check that the table was successfully created with a select statement against system schema where type is table. This select query will show us all tables that are in the database. Note that the results of the query are not displayed if you only run the first statement. We have to use cn fetch all in order for the results to show. So far we have an empty table. To populate the table, we have several options. If only inserting a few rows, we can use the following insert statements to input 3 rows into the employee table. And if you have many rows to input into the table, we can make it a list, and using the execute many command, we can insert multiple rows. Notice that we have replaced our insert statement from earlier with 3 question marks. The question mark here represents placeholders for the 3 items that we are inputting into the table. Let's look at what's in our table now. We can use the select statement inside the execute command, similar to what we did previously. From the output, we can see all of our employees have been correctly stored into the database table. Nice job. We have made a couple of changes to our database, but they are not saved to the database just yet. These are temporary changes, so we have to make sure to commit these changes with the commit command. If we don't, the changes will be lost once we close the connection. Last, it is always a good practice to close both the cursor and the connection once we are done. We can do so with the following commands: cn.close and con.close. This will close the cursor and the connection. One cool thing you can do is use both SQLite and Pandas together. Pandas has a read SQL query method that will allow us to return the data as the Pandas DataFrame. And from there, we can more easily manipulate the data in Pandas. Personally, I prefer bringing the data inside the Pandas to work with. We again have to first establish a connection to our database. Then we can use pd.read SQL query and save the output as the data frame called df_employees. Now that it is a Pandas data frame, you can use your usual Pandas function to manipulate the data as you wish. For example, let's say that our last employee in the table was never meant to be hired, so we need to get rid of him from the table. We can do so by calling the data frame and in the square bracket passing in the colon and -1. This will remove the last row from the data frame. And we can write our new data frame back to the SQL table and replace the original employee table with it. To write to SQLite from Pandas, we can use toSQL method from the Pandas. We can say df_new toSQL, and we need to provide 3 parameters inside this method. First is the name of the SQL table. Second is the connection to the database. And third, how to behave if the table already exists. Replace will drop the original table. Fail will raise a value error in the Python. And append will insert the data as new rows into the table. We can go ahead and run this cell, and this will update our existing table. We can check whether it worked as we expected by querying the table again to see if the last employee has been removed. And it has. Well done. And just like before, once we are done, let's close the connection. That's it. SQLite is pretty simple to use. If you're looking for a good database to practice SQL or SQLite, you can download the Chinook database. Link is in the description below. This is all for now. Thank you for watching. Let me know in the comments if you have a question or want to share a good SQL joke. Take care, and I'll see you in the next video.